I think we're ready. Here we go. Hey, welcome back. All right, so dimensional analysis conversions. Dr. J, how do you do it? How do you do it? Hey, this is weird. Wow. Okay, anyway, I'm looking at this lab book. I'm freaking out. Jay wants me to do pre-lab 2. Man. Okay, so we'll do some of these and get a little practice. Okay, so I'm going to come back to that though. First, I'm going to start with where do I get info on doing dimensional analysis? So here's a list of my steps that I use. All right, so the first step, it says what system are the given and desired units? And so the key to that is to look at the units. All right, and so we want to make a quick list here then of some basic stuff here. We got English and we got metric. You'll also see sometimes called SI. All right, that's just because the baseline for the metric system wasn't standardized. Whole big long story on that, but it basically came down to uh, they needed to get together and standardize it. A lot of money, a lot of national pride on each country had their own meter, for instance, and it was really getting out of hand. And so they got together in France and they came up with international standards. And so SI is French for international standards. All right, easy enough. We'll use them interchangeable. Most of the metric units have since been modified so that they use the SI standards. All right, so main things you need to know in metric, you're looking at grams and liters and meters. All right, you might also see seconds. But you're also going to see prefixes with these. So these are the base units. And so you're going to see stuff like kilograms and kilometers and millimeters and centimeters. Okay. And you just kind of get used to seeing, and what you're looking for are these base units. All right. English, you're looking at inches and feet and yards and miles and pound. What an abbreviation for pounds. All right. You've got ounces. You got the other ounces. Oh, no. You got gallons, um, cups, and pints, and quarts, and oof, man, headache already. Uh, and then we've got seconds as well over here. So we just want to be able to kind of tell these apart. But the main thing I want you to think of is these are being separated by a road. Okay. And it's a busy road. And so we can cross back and forth between these, but we only want to work in one system and cross one time. We only cross the road a maximum of one time. So if they start us off in the metric system and they ask us to end in the metric system, we don't ever want to go over into the English system. If we start in the English system and end in the English system, we want to stay in the English system. We really don't want to get over into the metric system. Where students tend to really get confused is when they start crossing metric to English and then back English to metric, and they're going back and forth. And I like to think of it as a big old delivery truck. It's coming through, and that's what you feel like. You got splatted by that truck. All right. Yeah. Too graphic to even draw on here. All right. So the only time we cross is when we're doing English to metric or metric to English, and we cross one time and one time only in a problem. All right, a maximum of one. So let's go ahead and look back over here at our list then. And so it says, where do we get this information? All right. So if it is English to English, if they're telling us to do an English to English conversion, we need to find that. And so it says usually they're memorized relationships. There's a list in chapter 1. They give a pretty good overview. The ones I require you to know are really, really easy. 12 inches is 1 foot, 3 feet is 1 yard. All right. I want you to know in 60 seconds is a minute, 60 minutes is an hour, 24 hours is a day, 7 days is a week. All right. And you need a 4 quarters is a dollar, 10 dimes is a dollar. Um, and then there's some weird ones that I don't require you to know. I'll put them in the problem if I want you using them. Stuff like we'll see in the lab, we have to use 2,000 pounds equals 1 ton. So that's always a handy one. You might have forgotten how to do uh, gallons and quarts and pints. Uh, so I'm going to go ahead and just give you a quick, uh, I'm not even going to run it down. I want you to look up, if you don't remember that, this thing called the Gallon Bot. And it's a teaching technique, and they draw a robot, and it's wonderful. Oh, best way to memorize it. But it's still a memorization tool. And so that is what the English system is all about, memorization. And that is why we struggle when we learn the metric system, is because we try to do it like we did the English system. And there's too many relationships. We make it way more complicated than it really is. And so if it is English to English, you're getting it from your head. If it is metric to metric, it says we're going to use the prefix table. What prefix table? Well, I'm going to come over here and look at this file that has my periodic table. And this is what I give you on every test, whether it's in person or online. I'll give you this file. It's linked in our course content. I'll put a new copy of it up there. But on the back of this periodic table, we've got a nice organized thing. This is actually found in your all this information is found in your lab book. This part's on page 100. This part's on page 116. Oh, you can't see that. Okay, here we go. This part's on page 100, and this part's on page 116. All right. The metric to metric is this table. All right. And this is the key to this is reading it as the symbol over here means this exponent. This symbol is what this exponent means. And so if I'm at lowercase m, it's milli, but it means 10 to the minus 3. That does not mean the 10 to the minus 3 goes with the m. It means the same thing. All right, it's fundamentally different. And then I have over here this list of conversion factors. This is where we're going to find our English to metric or metric to English. Now, the first three are interchangeable, and you use those to cross for distance. Easy enough, only use one. You can choose whichever one you want. I'll tell you that the 1 inch equals 2.54 centimeters is my favorite. It's an exact number. It works great, gets me into the metric system crazy fast, all right? 1 kilogram equals 2.205 pounds. If you're going in nursing school, you probably already have 2.2 pounds memorized. Now, how do you keep up with where does that go? Does it go to kilograms or the pounds? Well, the way I think about it is most people want their weight in kilograms because they weigh less, right? So 1 kilogram, you get about half the weight. All right, a centimeter cubed equals 1 milliliter. Remember, a centimeter cubed is the same as a cc. Oh, I love the way this is written compared to the way they do it in the book. In the book, they like to tell you 1,000 centimeters cubed equals 1,000 milliliters, which equals 1 liter. Wow. No, we don't need all that. It's 1 to 1. A liter equals 1.057 quarts. That's all I really need. Between those, I've got a few over here. Calories and joules we don't hardly use. Atmospheres, we'll use that later. All right. Pascal, we won't hardly use. So that's about it, right? And so a few constants down here we'll be using. But for our conversions, metric to English, English to metric, one of these. And then over here is our metric system, okay? And that is the key to this, is if you can figure out, which system it is, then you know where to go find the relationships. And I highly recommend then that after you find those relationships, you write them out, okay? So usually I like to start with either the desired units and work my way to the what they want, and I work my way kind of back to what they gave us. All right. Working backwards like that just cuts out a lot of dead ends. And what do they mean by keep in mind the relative sizes of the units? If you're starting in inches, it doesn't make any sense to go to miles to come back to yards. All right. It doesn't make any sense to go inches up to kilometers and then try to come back down to meters. You want to keep things kind of in relative scale. It'll help you cut down the number of steps. Keep in mind, dimensional analysis is all based off of multiplying by the magic number 1. And so if you're multiplying by 1, it doesn't matter how many times that you do it. But it can get you lost and cause extra trouble. All right. Then it says write down the given value and the units. All right. And so that's where we're going to actually start the problem. And then it wants us to set it up so that we cancel out. This is the hard step. If you've written down the relationships, then all we're doing is step 5 is putting the units. Okay. Don't worry about the numbers. They get in your way. And then we add in the numbers and then the units. This will guide us on whether we do multiplication or division. All right, so that's easy enough. Sounds good. So it says, for number 1, it says a 50 milliliter beaker has a mass of 42.503 grams. And it says make the following conversions, and it's got the mass in kilograms. So I don't actually need that 50 milliliters. They're just telling me what size beaker. So it's a beaker about that tall. All right. Well, about like that. Okay, so a little bit bigger than a shot glass. So 42.503 grams, and they want us to go to kilograms. So we're going to start there. Nice and big so we can see what's going on. All right, so first step, identify what system they're in. This is metric. This is metric. All right. So metric to metric, there's a max of 2 steps. Okay. This is the base unit to the prefix, or I could have gone a prefix to the base unit. Okay. So that's one step. The worst case scenario is I'm doing one prefix to another prefix. And so if I'm having to do that, we're going to do that as 2 steps where we go to the base unit. But we're already at the base unit. So where do I find this information? Well, I'm going to come over here. And I'm going to find the K. And so the K is right here, kilo, and it's 10 to the third. And so when I come write this down, I'm going to write 1 kg. And I'm going to replace this K with 10 to the third G. The 1 is still even there. We just don't normally write it. The G just got carried over. This 10 to the third came from that K. I'm substituting in for it. This is a direct substitution method. Once it clicks, you'll never have a problem with it. Always keep in mind the exponent goes opposite the prefix. Exponent goes opposite the prefix. This exponent will opposite the prefix. All right, so now I'm ready to do my setup. Now this is the setup. All this was to get started. Great work to show. But this is stuff right here that I'll be grading. This is the stuff I'm looking for in lab 2. That's where the points are. So it's 9 points. Something like 7 are in the setup. Okay. So here's my setup. I'm going to start with what I was given, 42.503 grams. And I'm going to multiply this. And what helps a lot of people is if you remember that this is over 1. All right. And so I want grams on the bottom so that they'll cancel out. And so I'm going to use this relationship. Grams on the bottom, that means kilograms will be on the top, which is good. That means I'll have kilograms left on the top. Always keep in mind what they're asking for. So grams go away, I'll get kilograms. Now the rest of this, that's the hard part. Once I've done that, that's the hard part. Here we go. I'm going to put the 10 to the third, and it says it goes with the grams. And I can double check it real quick. 10 to the third needs to be opposite that K, and it's a 1 up here. So this says I'm going to take 42.503 and divide it by 10 to the third. Now, if I'm typing this in, I'm going to get this E to the third. And you do that by hitting second, and it's the button EE. And it's above the, I don't have a calculator handy there behind me. It's above the 7. It's the button above the 7. All right. Remember, don't do 10E. That 10 is built into the E. All right. So second, EE, then the 3. All right. So I do this, and I'm going to get 1, 2, 3, I'll get 0.042503. And then you have to show your units. Now we should also worry about sig figs. Now, one of the keys to sig figs that we haven't really talked about in class a lot yet is this idea of exact numbers. And the problem with exact numbers, an exact number is something that was measured or defined. And so it has no uncertainty. So when I come over here and I look at my list of these conversion factors, now these are all exact numbers, okay? They're by definition. And I look over here though, it's hard to tell which ones are exact numbers. All right, so this 1 kilometer equals 0.62, 1 inch equals 2.54, 1 meter. So you can't even tell by the number of decimal places that 2.54 is actually exact. The other two have been rounded off. But how am I supposed to know that, right? Okay, so here's what I do when I grade these. I'm going to base it off of what we started with. Or if we're in lab and we did some measurements, then those measurements aren't exact. And so you'll base it off of anything that you measured. So for instance, we do density, mass over volume. You'll measure the mass, you'll measure the volume. But if we're doing just a conversion, then I'm going to let you treat all these things as exact down here. This is what you're based off. So we started with 5 sig figs. I need to end with 5 sig figs. And I ended up with grams. Okay, so that's how we do that. Now, I tend to run out of space and have trouble writing things. So these fractions, I start to curve them over. I start running. I've ended upside down on lined paper. How do you do that? All right, so what a fellow student showed me to do, I said, make this into a table. 42.503 grams. And then you come down here and you put your grams, you put your kilograms, and you get 10 to the third and a 1. And if this means the same thing as up here. And then I just say equals, I've got my answer. So what am I doing with this? Well, this up and down line, this vertical line, that is telling me multiply. That's my multiplication sign. And this line over here that's doing my horizontal line, all right, that's telling me to divide. All right. Now, you want to be careful when you're doing these. If there's any math on the bottom at all, then you have to put it in parentheses. So this 1 times 10 to the third, I left off the 1. I just kind of did that in my head. That's fine. And just did 10 to the third. But if I typed it in as divided by 1 times 10 to the third, the calculator would have very likely gotten confused, especially if I had that multiplication sign. So any kind of math, you need parentheses. Any kind of math on the bottom. On the top, it doesn't matter. All right. Well, man. Okay, that was a lot. Let's slow down and do another one then. So 42.503 grams is where they're starting us at. 42.503 grams. And this time they asked us to go to pounds. All right. So in this one, I can see that grams is metric. Pounds is English. So the first thing I want to do is try and find. So I'm going to come over to my list here. I'm going to try and find a conversion factor that has. Now, if I can find one that has pounds and grams, that'd be great. And I think your book has one. And I think you can find one on the internet. That's great. I would practice using these because these are the ones you're going to have on the test. All right. So here's one that says 1 kilogram equals 2.205 pounds. I'm going to go ahead and write that down. 1 kilogram equals 2.205 pounds. And I'm just writing it down exactly as I found it. All right. So exactly as we find it over here. And then I've got the problem then of I'm in grams, I need to get to kilograms. But we did that before. Kilograms is metric, grams is metric. We come over here, and I'm going to write down 1 kilogram. So we switch over so you can see what I'm writing. 1 kilogram equals 10 to the third grams, just like we did a while ago. So now I've got 2 steps. I've got the step that, so I'm going to label this. This is A, and this is relationship B. All right. Start with what I was given, 42.503. And I'm at an angle because I'm sitting on this wacky bench. So I'm going to go ahead and make a table. All right. Now I need grams down here, so they'll cancel out. This one, so this is B. B has grams, and it has kilograms up top. And then that means A will be over here, and I can take kilograms. I can either put kilograms up top or put them down on the bottom. I'd like to put them on the bottom so that they'll cancel those kilograms out. That means pounds will be on the top. And that's really all I'm doing is if I've written these down, right, then at this point, all I'm worried about is making the units cancel out. Don't overthink these problems. It's okay if they feel easy. Matter of fact, these setups, the way that the guy wrote this lab, he loved fishing. All right, this guy that wrote this lab, man, that's what he's doing probably. Oh man, it's almost 11. He's not fishing right now, but I probably spent the whole day out fishing. All right, this guy wanted you out of here, and so these tend to be very kind of repetitive. But that's not a problem. It's good practice. You just have to get over the fact that you're going to write some of these steps multiple times. So this 10 to the third, you just did that part. And then over here, you're going to have the 1 went with the kilograms and 2.205 went with the pounds. Shouldn't have to stop and think about it again. I'm going to look at it up here. Okay. So this tells me I take the 42.05, multiply it by 2.205, and divide it by 10 to the third. Or you could read it as divide by this, multiply by that. Just make sure you're careful that this is not in parentheses down on the bottom. I like to multiply all the way across the top and multiply all the way across the bottom and do my division. Or actually, when I write it, I divide. And if there's anything out here, I put parentheses. All right, so I do all the stuff up top, divide by parentheses, all the stuff on the bottom, multiply. Some people will do divide each step. That's fine. But I don't want you writing times 1 divided by this, times that divided by 1. Don't do extra. Don't make it harder on yourself. All right. So this is not much harder than the previous problem. Matter of fact, our answer will be 2.205 times whatever that previous problem is. And so you're going to say, Dr. J, can I just take the previous answer and multiply it by 2.205? Well, that's how it's kind of written. But I don't want you doing that. I'm going to grade this setup. So this is what I need to see. Now, if you already had it in your calculator and you typed in times 2.205, I don't care. I'm not going to know. This is what I'm grading. All right. So I want to see the setup. I want to see the answer with the units. All right. So these units will be pounds. When we do these, I know that they're repetitive, but we want to write them all out because when we do this on the test, I will not walk you through one step at a time like this. All right. So when it does the next one, it says go to tons. It's actually quite repetitive. All right. Now that's one we need a special one. 2,000 pounds equals 1 ton. If you've never dealt with elephants or cars, you might not know that one. So I give that one to you. I think I had them included in the procedure. All right. So here we go. We're going to do, this is metric. This is English. So we still had a crossover. Our only good crossover was 1 kilogram equals 2.205 pounds. And then we had 1 kilogram equals 10 to the third grams. We do this in 3 steps. I'm going to go ahead and set up my units, the 42.503 grams. Main thing is I care about, I'm going to go grams to kilograms, kilograms to pounds. We're just adding a step here, and pounds to tons. Very repetitive, but easy. But you got to write all this, come in, stick all the numbers back in. All right. Do your work, get the units. Okay. Now, when I read the next one, it said go grams to DG. And this is a classic example of something that the original author of this lab tries to pull on you all the time. Try to throw you a curveball. We add steps, we add steps, we add steps. Don't go to tons to try to go to DG. This is metric. This is metric. All right, so 1 DG equals 10 to the minus 1G. Be careful, there's a DG and there's a DAG. All right, so when I come over here, DAG is 10 to the 1 and D is 10 to the minus 1. So That's one step. Knock it out, no problem. Okay. All right. Let's see. Were there any others that might be tough? Inches to feet, feet to yard. Those aren't too bad. So then it asks us to do this accepted value. Okay, so percent error. And the way they write this is all kinds of confusing. All right, so this up and down line is absolute value. And then I want you to go ahead and treat it as parentheses. Now, what I do is you can do absolute value. You can hit second catalog, and it's the first one down. But man, just treat it as parentheses. What it means is if you get a negative, you write down the positive. You get a positive, you write down the positive. Okay. Now, they have the accepted value first, so that's fine. And so this is the accepted. Okay. And then accepted value. Then you subtract that from the experimental value. But the way this particular lab is written up, that's confusing. And we'll see why when you read the procedure. And then we're going to divide that by the accepted value. And then, since it has percent in the name, multiply by 100. Your units will be percent. Okay. So why do we do this? Well, if you're measuring things, let's say I'm going to build a model rocket out back with my a model rocket with my son, and we said, hey, wouldn't it be cool if we shot this and hit the moon? That'd be pretty awesome. All right. And then he says, no, Dad, let's build thrusters and make it land gently on the moon. All right. So we designed this and we built it in the backyard, and we were like, all right, let's try it. And then we wait for a place that we can shoot it off, and and then quickly get away before any police show up or whatever, right? Shooting things at the moon's a little frowned upon, especially when you live next to an air base. But so anyway, we shoot that thing up, and we miss it by 6 inches, right? Our jets give out 6 inches before they hit the moon. I'd say, hey, man, we did pretty darn good. We did really pretty close. That was a good shot. Way to go, man. Right? Then I go in and I show up to work, and we're gonna make some microchips. All right. They're hiring part time. I'm gonna first day of work. I'm gonna set this up. We're making microchips. All right, man. All right. I set that machine up, and I mess up my math a little bit, and it's off by 6 inches. Oh, now it's a big deal. 6 inches shooting at the distance going to the moon, not that big a deal. Pretty small percent error. And so what you want to do is divide by whatever the actual value is. So this accepted value or actual value, I usually write it as yours minus the accepted. It doesn't matter which way they go on the top. All right. Why? Because absolute value. So if you get negative, I don't know, 18, then you're going to write down 18%. If you got positive 18, you would write down 18%. You are smarter than your calculator. I know some of you don't feel like it in the first week. Relax. You'll get there. All right. So that'll get us through pre-lab 1 or pre-lab 2. Wow, we're moving fast. So once we're done with that, then starting on lab 2. So what I'm going to do is I'll pick some numbers. I'll put them in a data file, and you'll use those numbers when you do that lab. So that way you don't have to worry about trying to measure who's the tallest in your group or anything like that, because it's the calculations I care about. All right. So I'll make up some numbers. I'll put them in a file. I'll upload all this. All right. Take it easy this semester.